Hello everyone, this is TSS Zindabad and today we are going to discuss the daily challenge of Leetcode, which is maximum length of a concatenated string with unique characters. So let's jump into the problem statement. You are given an array of strings. A string S is formed by concatenation of a subsequence of array that has unique characters. Return the maximum possible length of S. So whenever we talk about subsequences have to follow the order, but we can delete some elements or no elements. So what does this problem statement says? It says that we will be given a string vector, right? So I have been given this array which has strings inside it, right? And what I can do is I can make different subsequences from the given strings in the vector, and I need to return the maximum length of a subsequence wherein every character is unique. Okay, so this is the problem statement. So let's talk about the approach. When we talk about the approach corresponding to this question, what I understand is that somehow this question is asking me to generate all the possible subsequences for the given strings that are available in the vector. So when I generate all the subsequences considering this vector, right? So when you talk about subsequences, as you know, the order matters, but we can skip certain strings, right? They do not have to be continuous in nature. So I can have different subsequences. So possible subsequences are I can have something like UN or UNIG or UNIGUE, or I can have something like UNUE. Similarly, I can have something like IG, IGUE, or I can have something like UE, right? So these are the different possible subsequences which can be created, right? So I have created these subsequences. Now after its creation, I need to figure out the maximum length such that that particular string has every character unique. So I come here, I see that U and N are different characters. So I can have something like a maxi variable, which is storing my maximum length, right? So I come to this subsequence and I see I have UN. Both of them are different characters. So the length of this string is 2. So I'll update my maxi to 2. I go to the next string, I see UNIG. All 4 of them are different. So we'll update with the maximum, right? So it is 4. You go to the next one, you get UNIGUE. Now U here is repeating. So that means every character is not unique, right? So we cannot consider this subsequence for updating the value of my maximum length. I go to the next one, again U is repeating. I go to the other one, I get IG. So the length is 2. But my maximum is already 4, so I will not update it. I'll go to the next one, I get IGUE. All of them are unique and its value is also 4. So maxi, which is the maximum length, it remains 4. You go to UE, the maximum length here is 2. But in maxi, we already have a 4, so we will not update it. Hence, the final answer turns out to be 4. So I have understood that what approach I will be following. Let's quickly write them in the form of steps. So we've understood which approach we will be following. Now let's quickly write them in the form of steps. So my step 1 will be to generate all the possible subsequences, right? The second step that I will be following is when I am generating that subsequence, right? I'll check if that subsequence is unique or not, right? Is unique or not. If it is unique, right? So what you have to do is you have to update the maximum length variable. And if it is not unique, you simply skip it. So these are the 2 steps that we'll be following. So now I hope the approach is clear. We'll quickly code this up. And then we'll use another example to have a dry run for the code. And then we'll talk about the time and the space complexity. Okay, so this is the problem. What I'll do is I'll say, let's have something like int length, right, which is corresponding to the length I'll have to return. And in the worst case, for example, if there wasn't any unique subsequence being created, so I have to return a 0, so I'll initialize it with 0, right? Then I can have a solve function, and in the solve function I'll pass a string, right? I'll pass the given vector, which is having different strings, and I'll pass the index for the same. And eventually I'll say you return me the final length, what you get. So now let's create the solve function. The solve function would again be of a void type. That is because I do not want it to return me anything. The length will it will automatically change, right? So I'll pass length here so that it changes. So what we can do is you can make it a global integer here, right? So that we don't have to pass it. So let's create the solve function, and in the solve functions, I'll give the parameters as string str. Let's copy paste this vector there, and we'll have the index, right? So let's have something int index. Now what I'll say is, I'll say that if at any point of time that string is not unique, so I'll be creating a unique function, which will be a Boolean function, right? I'll give it the string. So in that case, you simply return. We'll make the unique function shortly. So, or let's make it right now. So basically, I'll have something like a unique function. It will be a Boolean type, right? And it is getting a string, right? So it is getting a string s. What I'll do is I'll use something like a set. Set is used whenever we have to figure out the uniqueness. So I'll say just iterate over the string, right? And if you all, okay, we have already named the string s. So let's name the string as str, and let the set be s. So we'll have an str here. So we'll say that if whatever element you are on is already present in my set s, right? So in that case, that is not occurring for the first time. So it means it is a duplicate. So you will simply return a false. Else, if you have completed the for loop and you have not returned a false, that means every element was occurring just once. So that means every character in that string is unique. So we'll return a true. So now let's come back to the void solve function. After this, I'll say that if str.length is greater than the length that I've made a global integer as, right? So I'll simply change the value. So I'll say you get updated to whatever is the length of the string right now. So after that, I'll have a for loop, right? And that will work from the given index, right, till the size of the array. That means the number of strings the array has. And herein, what we'll do is we'll recall the solve function here, right? And now I'll pass the string str plus whatever is currently at that index. I'll pass the array and I'll increment the index by I plus 1. I think we're good to go. Let's quickly run and see. Okay, yeah. Here you have to remove an R because it is IT. Okay, let's see. What did we do wrong here? Okay, yes. So basically what is happening, there's a mistake in this is unique function. I am checking for the iterator, but if it is not present, that means it is coming for the first time. I also have to insert it, right, in the set S. So I'll just simply insert it here. I think we should be good to go now. and it is working fine. Let's submit it. And yes, it is working. Now, what we'll do is we'll quickly have a dry run for this and we'll discuss the time and space complexity for the same. Okay, so this was the code that we just worked on. Now let us assume that my array was something like CHA. It has the first element as CHA, then it has an R, then it has ACT, and then it has ERS. Now we'll have a quick dry run for the same. For the part of recursion, I will be forming the recursion tree as well as the recursion stack space so that it is easier for you to understand. So basically, we have something like a length here, which is initialized to 0. I call the first solve function. So here, I'll create the recursion stack space. And here I'll create the tree. So the first function call is made. Initially, my string is empty, right? And my index here is 0. So this gets added into my recursion stack space and my pointer is pointing towards it. I go to the solve function. I check is the string unique. So it says that there is nothing in the string. So, you have to, it's okay. You can simply move forward, right? Because here what you will get is it's like it's an empty string, right? So you will come here and you will check that is it greater, and no, it remains length remains 0 only because it is not greater. So you'll go into this for loop. Now when you go into this for loop, now I becomes equal to 0 and we have to iterate till the number of strings that are present in my vector. So here I can see I have 4 strings, right? So now another solve call is made. In this solve call, whatever is present on the 0th index, which is CHA in this case, right, that is added into the string. So now my string has CHA and the iterator moves by 1. So I here was 0, so it becomes 1. This function is added into my recursion stack space and now my pointer is pointing towards it. When we come to this function, now we'll check that is the string unique. So we'll figure out that yes, it is unique. So we'll get a true and we have to return if it is not unique, right? So it is as it is unique. So we'll simply move forward. We'll check that is the length of the string, which is 3. Is it greater than length? We'll say yes. We'll update the length to 3. Then we'll move into this for loop, right? So here when we come into this for loop, we see that the value of I now in this part here is basically I is equals to 1, right? So when we are here on I is equals to 1, we'll have another solve function wherein we'll add whatever is present on the first index. So it makes the string CHAR and I'll say increment the I by 1. So it makes it 2. So this function is added into my recursion stack space. I have something like CHAR in my string and 2 is the index. I again come to the solve function. I'll check is it unique. So after checking it is true, so I move forward. I'll check is the length greater. Yes, CHAR string has a length 4, so the length gets updated. Then now my I is equals to 2. So when it is equal to 2, I'll add whatever is present in the second index of my array, right? So that is ACT. So now I was 2, so I get CHARACT and the index gets incremented. Now when I again come to the solve function, I'll have something like CHARACT. So my map will start iterating over this. It will say C is coming for the first time, H is coming for the first time, A is coming for the first time, R is coming for the first time, but A is again coming. So that means it is not unique. So in this case, I'll get the false and I'll quickly return. That means I'll not be further exploring this. This was here, right? So I'll not be further exploring this function call. I'll simply pop it out because I have to return it, right? So I'll return. After returning, as I know that I have computed till I is equals to 2. So again, my code will start from the for loop and now I'll go to I is equals to 3. So now it says whatever is present on array 3, that is ERS, you add that into your string. So I get CHAR, that was already given to me, and we add ERS, which is on the index 3 in the array, right? And we call for the next index, that is 3. So when we come here, the solve function is called again, and now we'll be checking that is CHARERS unique or not. So what happens is it sees that yes, C is coming for once, HAR. Till here, everything is coming for the first time. E is coming for the first time. But again, when you see R is repeating, so it will return a false. As soon as it returns a false, we'll return from here as well. Okay. So as you know that this for loop is going till less than 4. So it has exhausted all of it, right? So what happens is it will also return. Now I have popped out these and my pointer is again pointing to CHA1 function. So what happens now is, yes. So what happens now is I am standing here. Now I have already worked with I is equals to 1. I'll say now you work with I is equals to 2. So this for loop is now running for I is equal to 2, right? So it says whatever is present on the second index of the array, that was ACT, you add that into whatever is present right now in the string, which is CHA. So I get CHA, ACT, and the next call is made, I is incremented, so it becomes 3, right? So in this case, here it was 4, I'm sorry. So now I'm working with solve function with this string, that is CHAACT. So my set starts working on it and it figures out that A is not unique here. It is occurring twice. So it will return a false. We'll go back to this function as it was added here in the recursion stack space. It gets popped out and it is again referring to its parent, right? So now I'll go to I is equals to 3. When I go to I is equals to 3, I get something like S and add whatever the strings had, str had, you add whatever is present on the third index of the array, that is ERS. So my string becomes CHAERS and I'll make a call for 4, right? Now, as soon as I enter the solve function, I'll have this string that is CHAERS. And here, as you see, all of the elements are occurring just once. That means it is a unique string, right? So my Boolean function will return me a true. I'll check that is the length greater, and I can see that here the length of the string is 6. As it is greater, I'll update the value of length, right? And after updating the value of length, what I'll do is I'll come here. Now my i's value is 4 and it should be less than 4. So I'll simply return, I'll come out of this function, right? So this function here is also completed. I am again pointing to my main function. Now, as it can go till up only I is equals to 3 because the for loop says that you have to move till I is less than 4, right? So it says I'm completed. You go to the main function. So now here what happens is that it had worked for I is equals to 1. Now the S empty string 0 will work from I is equals to 1 to 3, right? And further there would be furthermore calls. And again, we'll get different answers. I'll not be creating the whole recursion tree because it will take a lot of time. I hope this was clear. And in the similar way, you will finally get that 6 is the maximum length of the unique subsequent string that can be generated, right? So now let's quickly talk about the time and the space complexity for this code. So as you can see, here we are using something like recursion, right? So when you're using recursion, what happens is you are again and again iterating over the strings that are present, right? You're trying to figure out, you're having a for loop. So the time complexity becomes big of 2 raised to the power n, and the space complexity in the worst case scenario is O of n. That is because of the recursion stack space. Thank you so much for viewing the video till the end. If there is any doubt, you can always comment and we can discuss it. Please like, share, and subscribe. Thank you.